After completing this lecture, you can describe the AI development process. What does it take to build an AI model? If you're an architect, I will leave it to you to compare it with the stages in the design process. There are three major phases for developing an AI model: training, testing, and deployment. Remember that, like designing a building, the engineering of an AI model is an iterative process. In the first step, after choosing a proper dataset that contains relevant information for the required AI model, the dataset is divided into two non-overlapping portions: train set and test set. The model is trained on a train set and tested on a test set to benchmark the performance. Once the results are satisfactory, then the model is done with learning and is set for deployment. After the first beta test, which is based on the product that is nearly complete, the model is released to a limited audience outside the development team. The user feedback then is used to fine-tune the model, which may include more training and testing. Take this collection of ellipsoids as a dataset. Each ellipsoid is a data point in this dataset, representing different size, color, and shapes. Assume that this is a dataset that we want to use to develop a computer vision model that can classify the shapes into circles and elongated ellipsoids. In the first step, we randomly divide the dataset into train and test sets. The train set is often the biggest portion, as you would like to use as much as data to teach the model about the task. The test set is not shown to the model during the training process. But what is training? Training involves using the train set to adjust the parameters of the machine learning model through iterative optimization techniques to minimize a loss function and improve performance. There are a few important concepts that are underlined here. I would like you to search these keywords after watching the lecture and try to learn more about them. The training process involves dataset curation, model selection, and the choice of learning algorithm, as well as a cost function that is used to guide the optimization process. Once the model is trained, it is time to evaluate how the model has learned the task. This is done on the test set. That is the data that the machine learning model has never seen before. The reason that we keep the test set a secret is to evaluate the generalizability of the learning process. Generalization refers to the ability of not to remember the training data, but to learn the general rules instead. In the context of our toy dataset, this means not learning to associate the color to the shapes in the shape classification task, but learning what makes an ellipsoid a circle. In other words, the machine learning model needs to attend to the shapes for this particular task, not overfitting to the misleading color information in the dataset. This is examined in the test set, the original color test set, of course. Testing a machine learning model is the process of evaluating the trained model on the test set to often assess the generalizability and the accuracy of the model. The accuracy, or loosely speaking, the precision of the model, is how many times the model gets it right. Accuracy reflects on the performance metric, while generalizability tells something about how reliable the model is. If the performance metric is satisfied, then the model is off for deployment. If not, the model needs to be trained again with more data or another model until it passes the required performance specification. After several iterations of training and testing, once the model performance passes the required specification, It's time to start the deployment process. This is when our well-trained and tested machine learning model is integrated into the AI product. The model is now tested with real-world data and real users. The feedback is collected from users and the accuracy is re-evaluated on how well the model can make predictions or make decisions under uncertainty. Note that the deployment step is applicable to AI product development, and often AI researchers stay backstage, working with well-curated and controlled machine learning datasets. In the context of our TOI dataset and shape classification task, this could be an example of real-world data, where there exist not only ellipsoids but other shapes, and the model should be able to still distinguish circles from other shapes. What do you think? Is the real-world data, in this case, on par with our test and train data?